Hello again, class. This is Craig, and here's the spreadsheet I promised you, where I am going to show you how to calculate confidence intervals for a population mean and also for a population proportion. In each case, the population standard deviation is unknown, and so you will have to be careful to be using the t-distribution for the population mean, but you can still get away using the z-distribution for the population proportion. Let's see how it works. Over here in column A, I have some data. And how many values do I have? I don't know, a bunch. But we're looking at shoe size is what we're looking at, and they range all over the place. And what I want to do is calculate a 95% confidence interval for shoe size. Well, okay, let's just jump in. First thing, I'm going to have to gather some statistics. First of all, I need what's called a point estimate of the mean, or our best estimate. And we can simply do that by calculating the average using Excel's average function. And I hit enter, and sure enough, average shoe size is 8.97. And how many values were there? Wait a sec. Oh, okay. That one we use the count function. You guys probably remember this. Give me the range. Shows up there. I can just hit enter at the end. I had 29 values. Degrees of freedom. We're not going to be using in this exercise, but degrees of freedom are always n minus 1. And you can read about what degrees of freedom are. In fact, I'm just going to skip it. We don't need it. Confidence level. Well, we said we want a 95% confidence level, so I'll put 0.95 in there. Alpha is 1 minus our confidence level, so 1 minus this cell should give us 0.05. And now I need a standard deviation, so I'm going to go STD, and now we have several different possibilities. The first one, STDEV.P, says that's for the entire population. Oh, we don't want that. We're doing sample standard deviation. And STDEV.S will give us a sample standard deviation. STDEV is for 2007. You can also use that one. Either one of those will give the same answer. I'm going to use STDEV.S, get in the habit of using this newer function. I just hit my tab key. And now it wants my range. So I grab my values. And there I have a standard deviation. At this point, I want to refer you to page 359 in your text. In figure 8.4 at the bottom of the page, they show you, your author shows you how to use Excel to calculate this confidence interval. Study this information. In particular, I want to look at the margin of error section. I'm sorry, folks, I'm trying to find a page. Okay, yeah, just on the prior page, equation 8.1 in the middle of page 358 shows again what our equation we would use if we knew the population standard deviation, but we don't. But anyway, let's look at that equation. It's x bar plus or minus the z statistic times sigma over the square root of sample size. Now, in the spreadsheet on page 359, the margin of error is equal to the second half of equation 8.1. It's equal to the z statistic times a standard population standard deviation divided by the square root of sample size. And the equation, as you can see, the formula in Excel that you would use to calculate this is the confidence.norm equation. Well, that would be nice if we had population standard deviation, but we don't, and so we can't use that equation. However, we can use one that's very similar to it, and it's the confidence.t equation. And I'm jumping back to Excel now, and I am going to use my formula editor, and I'm going to insert a function. And let's see, I'm going to type confidence up there, and there it is, the first one that came up. I'll say OK, and here's the dialog box for it. First of all, we need an alpha level, and I have that. It's right there. Standard deviation, we calculated that. And finally, size. This is the sample size, and our sample size is 29. Gives me a look ahead, says your margin of error is 0.5. We say OK, and there it plugged it in. There's our equation to get the margin of error, which again is everything after the plus or minus. And using now our point estimate of the mean and the margin of error, we can find the range, the upper and lower limits that define our confidence interval. For example, the lower confidence limit is going to be equal to our point estimate. Not equal. Minus the margin of error. And the upper limit is going to be the point estimate plus the margin of error. Voila, there's our confidence interval. How do we interpret this? This is important. We say that we are 95% confident that similarly constructed confidence intervals would contain the true value of the population mean. Or we can say that we are 95% confident that the true population mean falls within the range 8.46 to 9.47. All right, one last piece of information you were asked for is the maximum error that you could be making if you were using this confidence interval. Well, let's see, if we assume that the true value, and it's our best guess of the true value of the population mean, is 8.97. And so if that was true, that sits right in the middle of our confidence interval. And so the largest error we could make would be the difference between one of these limits and the point estimate of the mean. Or we can just similarly calculate the difference between those, the upper and lower limits, and divide it by 2. I'm going to do that. I'm going to say bigger value minus the smaller value and divide that by 2. Biggest error I could make is 5.23. Something doesn't seem right. Let's look at that equation. I did it on purpose. Anybody see what my mistake is? What Excel did in this equation is take D17 and subtracted 1/2 of D16. That's not what I wanted. I'm missing a couple parentheses. There we go. There's the maximum error we can make. Okay, let's now turn our attention to the right side of this workbook, and now we're going to calculate the confidence interval for a population proportion. Again, our population standard deviation is unknown, but it doesn't matter for proportions. We can still use the z-statistic. Okay, first of all, the biggie I need to get is a point estimate of the proportion of shoe sizes that are size 10. The equivalent was the point estimate of the mean, but now we're calculating a proportion, so we need to do things a little bit differently. We're going to have to count the number of size 10s and divide by the total number of values. That's our definition of proportion, wasn't it? So, count of size 10, I can use the COUNTIF function. It has two parameters, a range and a criteria. First of all, the range is simply our range of values. And I put a comma, and my criteria is I want to know how many 10s there are. And there happens to be 10 of them. Is that right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yeah, looks right. Okay. How many values in all? Well, we could just copy the 29 over there, but I'll use the count function. Count up these values. Yep, we still have 29 degrees of freedom. We're not going to worry about yet. Next week we will. Point estimate of the proportion. Well, to calculate that proportion, all we do is take the count of number of size 10s we had and divide it by the total. And we have, looks like just over 34% of our values are size 10. Confidence level, again, is 95%. Whoopsie. Let's undo that one. Confidence level is 95%, and the alpha level is going to be 1 minus our confidence level, 0.05. Standard deviation should be the same as it was before. Let's check that out. STD EVA, and grab my range of values. Sure enough, same value, 1.3224. Now the z-statistic. It's not quite as easy. There's not a nice margin of error function for doing proportions in Excel. So we need a z-statistic. Now we said we're doing the 95% confidence interval. And again, we can turn to page 359 and look at that little table. And it tells us for the 95% confidence level, the z alpha over 2 stat is 1.96. That's the value we want to place in here. 1.96. And now we can calculate the standard error, and I'm going to turn to page 379. I'm sorry, page 377, and equation 8.6 shows how we're going to calculate our interval for a population proportion. It's our best estimate, our sample proportion, plus or minus the z-statistic times the square root of p times 1 minus p divided by n. And the standard error is a term that we use, and for calculating a proportion, the standard error is equal to the square root of p times 1 minus p over n. Oh, no, I forgot. You got to put the z in front of that. That's equation 8.5. No, that's the margin of error. Where is the standard error? Prior page, perhaps? Oh, Craig, you lost it. That's okay. It's not critical. I'm going to pause and go find that. That didn't take long. The standard error starts with the square root. And what is standard error? Well, you probably read about it, learned about it. It's probably confusing. If we have a population and we calculate the standard deviation, that's fine. But if we have a population and we take multiple samples, and from each of those samples we calculate a mean and then take the standard deviation of those means, that's called the standard error. It's used many different places. Okay, so standard error is going to be, again, it's that everything under the radical, so I'm going to use the square root function times my population proportion times 1 minus my population proportion divided by n, sample size. Let me look at my equation. Let's see. I'm going to count the number of left parentheses. I've got 1, 2, and it's got to equal the number of right parentheses. 1, 2. Looks good. There's my standard error. And now I can calculate my margin of error by taking my population, my point estimate of the proportion. Nope, don't want to do that yet. Nope, the margin of error is simply equal to the standard, or equal to the z statistic times the standard error. There's my margin of error. That number is going to determine my upper and lower confidence limits of the proportion. So now I can calculate those by saying point estimate of proportion minus margin of error, and the point estimate of the proportion plus the margin of error. And finally, we can say that the maximum error we could possibly make, if this is our confidence interval, and if the true value of the point estimate is equal to 0.34, would be equal to that margin of error. We calculate it over here by taking the difference of the upper and lower limit and dividing by 2, but it turns out we calculate it as the margin of error, so I'm just going to say equal to that cell, and there it is. Don't know why it's italic. We'll turn that off. There we go. It's also centered. Isn't that interesting? All right, folks, I hope this has been of help to you. You will be doing a very similar thing, although you'll be looking at some different things than I looked at. You won't be calculating shoe size statistics, but you'll be doing things in the same way that I did. If you need help or assistance, please, I'm available for phone calls, and I'm hearing from a couple of you, but it's been a while now. Of course, we had our 2-week break. If you need help, be sure to drop me an email and we'll set up a time when we can talk. And talking about this stuff, your CT assignment is perfectly legitimate in my mind. See you soon.